Welcome to Tech Inspection, the show where we dive in depth into drag racing technical topics, and I am joined by my co-host, Brian Wagner. What's going on, dude?
Well, this week we're going to be hitting on the magic that is these radial tire shocks now and how these packages work. You know, there's the way that you work with a set of slick tire shocks on a car versus radial tires are completely different. We've got some awesome guests coming on today to talk about that. We'll get into that more later as they kind of pop in. But, you know, we're just going to look at the different kind of shocks, you know, single adjustable, double adjustable, talk about that, triple and four-way shocks, air shocks, you know, shock separation, and, you know, why they make adjustments to these shocks in different situations and how they do it, the whole, like, process behind it, because it's really different with a radial tire shock versus a slick tire shock. So it's going to be an education, and it's going to be fun.
I am definitely looking forward to it. And then our guests, we got Mark Menscer. If you don't know who he is, you definitely check out Menser Shocks. They do a lot of different custom shock builds for a lot of different builds around the country. We've also got Patrick Barnhill, and then hopefully, if we have enough time, we're going to try and hit up David Reese and get him on the show as well. And all three of these guys are insanely smart, and they know what they're talking about. But before we dive into any of that, let's just get right into the fun segment. And Wagner, you got a pretty funny video heading up about the Supra that makes all this power on the dyno, but something else happens. And go ahead and let's dive right in, man.
You know, you see these guys riding in the back of this Supra on the dyno, which I'm not going to fault them. I've sat in the hatch of my own car on the dyno when the dyno operator's making a pull because it would spin on the dyno. Totally cool. However, the mistake that we see being made here is the position of the legs. You have to be paying attention where the exhaust is, and these cats find out why when this thing decides that, you know, it wants to kick the muffler off, and thankfully that was it, and it didn't hurt anybody because that could have been some light trauma along with a burn in a hurry. There's a lot of bad decisions made just across the board.
There's just so much going on there. I mean, it's a Supra, so you would assume, like, okay, it's probably like a pretty nice, well put together car, and then he hits it looks like they hit the limiter. Am I right there, Wagner?
Yeah, there was definitely the moment of maximum intake danger to manifold, and, you know, the floor pan that dropped out the muffler just decided it wanted to go exit stage left.
All right, so that was our fun segment. Thanks again, Wagner, for getting that on for us. And now we have the man, Mark Menscer, on the show. Mark, what is going on, dude?
Hey, guys. How you doing?
Well, I think to kind of, you know, kick things off here, Mark, something that, you know, kind of get your take on this with, you know, shocks in general with radial tire shocks. You know, you hear about single, double, triple, four-way air shocks, you know, all that stuff. You know, how do these different shocks kind of work in a radial tire setting for someone that might have, like, you know, myself, a 9-10 second street car? You know, what kind of shocks do you want to really look at for if you're running radials, and, you know, how do these all work? You know, what do you want to use? What's a good baseline?
Well, there's a myriad of products out there. As you mentioned, double adjustable, single adjustable, triple adjustable. Usually the way that we kind of try to break that down is based on horsepower. And then we try to talk to the customer and figure out what their ultimate goal is with the car. So you might have a guy that's got a 1,000 horsepower car that runs, you know, mid fives or something in the 8th mile on radials, but his ultimate goal might be to make that a 4-second car. And if that's the case, sometimes we'll recommend a little more shock than he needs so that he can grow into it. Or if he's happy where he's at, you know, then we can set him up with a product line that's gonna work for what he wants to do. So your single adjustable stuff might only adjust on rebound, or it might only adjust on compression. So you can buy those either way. And you'd spec that depending on what type of car you had. Like if it was a leaf spring car, the compression is less effective, so you would spec a rebound adjustable only shock for a low to moderate horsepower leaf spring deal. Kind of similar situation with ladder bars. When you get into stock suspension and four-link, compression becomes really important. But with a radial tire, that extension is controlling how much traction you're making available to that tire. So you really need to transition into a double adjustable shock at that point. As horsepower grows and ET starts to come down, That's when the idea of triple adjustable, four-way adjustable, air-controlled shocks, shocks with internal bump springs and rebound shutoffs and all this sort of stuff. Those are very custom tailored to specific applications in really high horsepower, low ET cars, 3-second cars or bottom 4-second cars.
So, Mark, I want to pitch you a question. In 1 or 2 sentences, what is the most important part inside a shock? Go.
The fluid. Absolutely the fluid. I know that sounds ridiculous, but you could build a shock with a piston that didn't have any moving parts and no shims, and you can tune it with fluid. The weight of the fluid, the viscosity, and the thermal characteristics are absolutely critical.
The one thing you'll see with radial tire cars or slick tires cars is one likes to squat and one doesn't.
Yes.
With what is the thought process, the philosophy behind that extension? Is that different for the different power adders on when it comes in? People always kind of comment on the photos like, why does Marcus Burt's car look like it's trying to transform? What's up with that?
So on a car like Marcus's, when you figure out where the engine placement is and the weight bias of the car, those things end up, that engine is massive, and that's a very lightweight combination per the rules in radial versus the world. So you end up with a car that's heavy on the nose. It takes a tremendous amount of starting line traction to get that thing moving. Once you do, the way that they're putting the power into that thing, which is basically like with a sledgehammer, it all happens so quickly the car wants to wheelie, as you saw down at SGMP when it took flight. So the idea there is to extend the back of the car fast enough and far enough so that the rear center of gravity can over center the front center of gravity. In other words, you want to drive over the nose instead of under the nose. So it's a two-part scenario. One, we're trying to make enough traction initially to get this thing moving. And secondly, once we've got all that traction and we're applying all this power, those guys are turning kits on, locking stuff up. I mean, it's going bonkers all in like 1 second. We have to get the back of the car high enough in the air that it pushes the nose down so it doesn't flip over backwards.
That makes a lot of sense, and it's interesting to see how the different cars do that, because another car that you see, I've gotten pictures that do that, was when Big Chief had the Crow mod. It was the same thing, and it looks like with a turbo car, since the power curve is so much different, that with radials you really have to be able to use those shocks to get that extension and match all that up to the power management, correct?
That is correct. So, I mean, obviously anybody who's looking at data knows that a nitrous car, once you've turned everything on in, say, a second, it's done. It's just, the thing is just cruising down the racetrack now. So that G meter would come up and it would peak, in that area of 1 second, 1.3, somewhere in there. Now your turbo guys, they'll see an initial high G meter, but then they'll hold the G meter. Like a twin turbo Hemi, that thing will hold a tremendous amount of G meter all the way through the run. Basically, it'll hold the G meter until you let off the gas or the cylinder heads fly off of it. So with the turbo car, you're looking for your shock graph to peak out later in the run when that thing is making its maximum horsepower and maximum torque. That deal makes 5,000 horsepower at the 330. So we need the shock extension to take longer and give us more of a mitigation effect there, so that the suspension is growing throughout the run. The nitrous car, you get it all up there in 1.5 seconds, it's done, and now it's just cruising down the racetrack.
That's perfect. I mean, that definitely sums it up for sure for that question. That dots all the I's there. Petty, what do you got?
So my next question is, when should somebody look into getting a custom shock? Because there's a lot of different options on the shelf from a lot of different companies, or maybe they've got a combination they've had forever. They've got a big tire car, small tire car, and it just goes consistent 125, 130, and 60 foot. But when do you think it's really crucial to look into having a custom shock, and why?
The shock valving itself is a part of that equation. So when we say custom shocks, what we mean there is that a company like ours or another company that does the same thing would take all that combination information into account and then create a valve code for the shock and match that to a spring rate and then give you a package that you bolt onto your car. That slow guys that are running 10 seconds can still use that information. It is all about consistency, and it's about tuning, and it's about the resources that come with purchasing that package. So what I would tell somebody is, if you have a racing program and you're looking to consistently grow your knowledge base and make your program better, that a custom shock is really not dependent on how fast you go. It's all about spending money with a company that has information to follow up behind their product and to keep teaching you how to race your car better. So we don't just sell a shock absorber. I mean, I help my guys with 4-link. I help them with chassis tuning, with weight mapping. I help them with their power management. We look at data. So we become a part of their race team. And I think that's probably more critical than the actual shock valving part of that question.
So I just had one follow-up question, and then I'm good. How often should somebody be checking, looking, and servicing their shocks, like their rear shocks? And I know that's probably going to vary depending on, like, oh, I got a 12-second bracket car. Oh, I got a 3-second radial car. Like, just talk to me about that.
If you have a gas-charged shock, like a canister or a remote reservoir type shock, you need to be checking the gas in your shock every time you unload your car at the racetrack. And that means every morning when you unload it, from qualifying to eliminations to whatever, every time you get that thing out of the trailer, you need to be checking it. You need to look at those shafts and look at those seal heads and make sure you don't have fluid present. And if all those things are good, typically every year there's going to be updates and new information, or it's a good idea to get them in and get them serviced anyway. They've got parts that wear out inside of them. So it's every year you need to be looking at them.
So Mark, now I want to talk to you about high speed, low speed. When did that come about, as far as shock technology goes, and why they're so important on these really high horsepower cars?
So the split between high speed and low speed, that tunability's been available for a while, but it's something that came from road racing and circle track racing. It wasn't used tremendously in drag racing. But the idea in tuning high speed and low speed is like the hit of the tire, that initial movement. Usually that's a high speed event. You see these massive velocity numbers, 18, 20, 21 inches a second of shaft velocity. The low speed is the rate of rise, or the rate that the car goes from ride height to full extension going down the racetrack. And on our radial cars, it's absolutely critical to be able to differentiate between the two at some point when they get fast enough. You have to hit the tire hard enough and fast enough to get it stuck on the starting line. But then we can't just use all of our shock travel up, all in one instant motion. So if you take like a nitrous car where the shock maybe takes a second and a half to fully extend, but then we've got a turbo car where it might take us 3 seconds to get to full extension on that shock. That's where you're going to be separating and differentiating between your high-speed tuning and your low-speed tuning. You can go ahead and crank down on that low speed and slow that rate of rise, or if you've got a car that wants to go out there and pick the front end up early, speed that rate of rise up, get the back of the car up, and shove that front end right back down on the ground.
Yeah, I mean, that's so important when it comes to, with the weight transfer and how it works with a converter and everything else. And I think that's going to give our viewers an interesting take when they see these cars, when they leave the line, what they're doing and why it's doing it, why it comes unglued. I mean, that's really, really awesome and good knowledge right there about that speed for sure.
Yeah, and I think something that we've learned with the radial tires, as we've experimented with wheel widths and stretching that tire out, bead locks, tire pressure, and then the weights, these minimum weights for the classes have kind of started to come down. You find that at some point you've got too much velocity and you hit the tire so hard that you've actually overloaded it and it bounces off the racetrack. And so when you're able to tune that out of there, you can still have the rate of rise that you need. You can still have the aggressive suspension, the real short, mean four-link, or the really aggressive ladder bar angle or whatever. But now you've got a shock that gives you the tools you need to tune that hit, that first couple of feet of the racetrack, without affecting everything that happens after that. You hate to have to make a shock adjustment for the starting line and then be married to it for the rest of the run.
Yep, it's the biggest thing when you talk to racers, that, especially with the pro mods on radials now, that they talk about, is that the radials feel, with the suspension and the tire itself, just it feels more planted. It's not as washy. As soon as it hits, it's a go or a no-go situation. And a lot that has to do with how, like you said, how you have that suspension set up, how it hits, how it plants, and how it goes. And then that pretty much sets the path what it's going to do when you go down track.
That's correct. When the radial tire, there is zero slip ratio with a radial tire. The slick tire is in slip all the time. That thing is quasi spinning its way down the racetrack. So with the radial, every amount of motion is converted into acceleration. And so the way that you tune the shock and the way that you manage that, the frequency of the tire is different. Because the radial tire it's just rolling down the racetrack. It's not slipping. There is no high frequency chatter going on. And I think that's what these guys are noticing when they switch over from the slick to the radial. It feels like a highway tire. And when you accelerate it very quickly, it allows you to put power in from zero, the release of the trans brake button, so much faster than you can with the slick. Because the slick, it starts off spinning, and then you mitigate that wheel speed down. You feather it into a 1-to-1 ratio, and that's all power management. You're doing this little dance, and you have to wait on the tire and wait and wait and wait, and then you can finally get all your power in, and you go down the racetrack. The radial is like, give me more, I'll take whatever you got. And then if you don't flip over backwards, once you've got it hooked up, there's practically no limit to how quickly you can feed power to it.
You're killing us, Mark. We could do, like I said, we could do a whole hour-long show easily, or bring you on for other stuff, the suspension and tuning-wise. So, yeah, definitely. If you're down, we'd love to have you back on the show at some point for sure.
Absolutely.
Yeah, I would love to. Yeah, we'd love to talk about that tire, too. Phil Schuler told me one time that the Radial versus the World is the closest thing to Top Fuel that you can get with doors on the car.
Yeah.
All right, I just want to thank Mark Menscer for coming on the show. That was really cool, picking his brain and really diving in the deep tech of radial shock construction and the different things there. And now we have Patrick Barnhill with us. Patrick, what's going on, man?
Doing great. How you guys doing?
Good. We are doing fantastic. So I'm just gonna dive right in, and I want to talk to you and get your feedback about radial suspension setups, adjustments, and just get your overall, like what kind of adjustments and what are you looking for in a radial shock on a race car?
Well, oddly enough, you mentioned that you had Mark on right before me, and couldn't have a better guy with that stuff. He's actually the genius when it comes to most of this stuff in the radial tire world. I did some stuff with Mark recently on some shocks that we used his four-way valving shock, but we used some CO2 pressure to vary some things on the shock as we were going down the track. Kind of some new stuff that he's been working on that we did some testing with him on. Utilized it on Tom Blanco's car a little bit, and actually did really well with it. So kind of cool stuff on the shock, like the forefront or on the horizon here that Mark's been working on, that we can maybe all see on everybody's car here in a couple of years.
Patrick, kind of going off of that, you're a well-known tuner across the board, and I mean, you've tuned anything and everything. I always tell people, if you see Patrick with a car, it's probably going to be going fast or trying to go fast. When you're tuning on a radial tire shock car, what do you look for in the magic tuning window when you're looking at the track? Do you look at just specific track conditions? Do you have to weigh in the power adder on the car? How do you massage the shocks?
No, you definitely have to weigh in the power adder, because they all apply differently. For a turbocharged car applies power so much differently than a ProCharger type car. I can't really speak of nitrous too much, because I'm really not much of a nitrous tuner, but the ProCharge and the turbo applications, they apply everything so differently that you have to run the shocks a little looser for one, a little tighter for the other, because the ability for the shock to withstand topping out is kind of the magic there. Once that shock reaches its full extension, you might say, a couple of things happen, either spins or wheelies usually. So the magic there is to try to keep it to where through that first 120 feet, 130 feet, it's not topping out, because that's really the critical spot on the radial tire.
So, Patrick, I had a couple questions, and I'm asking these to everybody, all the guests that are on today, and I'm going to pitch them to you as well. Number one, in one or two sentences, what do you believe is the most important part inside a drag radial shock?
I mean, the way Mark is setting up the valving is 100% to me the most important part. You know, the ability to give you the fine adjustments that allow you to make this all work. You know, when we had shocks back in the day that had, 8 adjustments on them, you really didn't have much. Every time you'd click a shock, it made such a gigantic move that you could never fine tune it. So when it comes down to it, it really, guys like me, we just look good because guys like Mark know what the hell they're doing. That's what it boils down to.
Perfect. And then the second question is, how often do these types of shocks need to be inspected, serviced, and then also potentially rebuilt and sent back into the manufacturer? What do you think is good, like a good guideline for inspecting and rebuilding shocks like this?
Well, normally that's something that gets forgotten on a race car a lot. A lot of people buy a set of shocks, they throw them on the car, they don't think about them ever again, and that's really the wrong way. It's a racing part. It goes through probably more movement and anything else on the race car. So when you're looking at that shock, I would say, in the off season when everybody's sitting at home doing nothing, or when there's the COVID-19 virus, send them in, get them looked at, get them freshened up, because a lot of times you don't realize that a shock's starting to go bad. You start to see the performance of the car suffer, and then you start making changes and making changes. But what you don't really realize is that something in the shock package is going away, just needs to be freshened up or changed. That's all.
That's good. Now
you find yourself chasing your tail over something that could easily have been, counteracted if you had just sent it in the first place.
Something I was curious to get your take on with, radial tire, specific like shock tuning. It's going to be a little bit different than slick tire. We can get into that a little bit more here in a second to compare and contrast the two. But when you're looking at what adjustments need to be made on a radial shock for the present conditions, you always hear people talk about making clicks and whatnot. What are you looking at to adjust on a shock based on conditions for, greasy versus tight track? What are you guys trying to do, or is that already baked into the valving and all that stuff?
Well, that's what's neat about the stuff Mark had worked on for us that we started to run, at the end of last season. That's a dynamic change based on CO2 pressure that I'm able to put on the shock. So I can have the shock be very, very loose and extend very quickly on the initial hit of the tire, and then 3/10 into the run, I can change it all and make it tighten up a little bit, so it doesn't try to extend so quickly that it tops out. So, but when you come to adjusting a shock that doesn't have all those cool features, and you're just a manual adjustment, you just look at the racetrack and see, whether it has some teeth or whether it doesn't, on how quickly you want that shock to extend to apply the tire into the ground. And you kind of have to make those adjustments before you get up there. But the stuff that we're working with, like I said, it's a dynamic deal where you actually draw. I use Haltech EFI systems, and I use a method of controlling the CO2 to the shock through the ECU. So I draw a graph of what I want that shock to do.
Wow.
So when we let go of the trans brake button, we're controlling how that shock comes in and out.
That's crazy.
That is crazy. I love that you brought that up, because it instantly made me think converter dump valves. You can have a completely different torque converter at the starting line than you do 200 feet out. And from what you're saying, you can have a completely different shock in the front half versus the back half and even the middle split. That's just wild to me.
No, absolutely. And that's something that we do right now is we change that stuff, like I said, dynamically as we go down the track based on how the car is performing. So, and then you can also take with that particular ECU, you can take sensors and input them back into it that can actually modify that shock tune-up based on a ride height sensor or based on other factors as well. So it's all changing as the car is moving down the racetrack, and some of it is programmed the way you want it, and some of it sees a sensor and makes a change to make it a little bit better.
Do you ever think, you've been around, this radial tire stuff, Patrick, since it's, kind of blown up, with Ducks races and everything. Do you think that what you guys are able to do with the shocks now is some of the most important technology with radial shocks to make these cars do what they do?
I think that there's like three things that really have changed the game. And one of them was shocks for sure. The shock technology has 100% changed the game with guys like Mark getting involved, in producing products that are far better than off-the-shelf stuff that we used to run, back in the early 2000s and so on and so forth. The other two variants that have changed the game completely has been the tires that Mickey Thompson has produced are far superior in this application right now and than what we used to run. Because if you remember, when all this started, we ran a BF Goodrich drag radial back in the day, and we used to run those things around the pits flat to break the sidewalls down to try to make them work better. So it all started there. Then the Mickey Thompson tire came out and totally changed the game, and they continue to evolve. And then, of course, the guys that have gotten involved with the track prep, the surface itself, because I don't care whether you have great shocks, great tires, but if you don't have a great surface, none of it works. So it's a little different in the big tire world. The big tire world, you can get down the track on a little less than average surface. The radial tire world, if the surface is really, really poor, it's going to be a struggle for everybody there.
I think this is a really interesting topic that comes up, and I think it's going to continue to come up in every single episode of Tech Inspection. It's like, okay, we're talking about shocks, and it's like, yeah, so shocks have come a long way, torque converters come a long way, all these things have come a long way, but so has literally everything else.
It's funny, I learned a long time ago doing this stuff, back in the 2000s, that if you try to save a buck, it usually costs you $2. In some cases it costs you $5. So buy the right shit right from the get-go. Don't mess around. Anyone that's trying to do this on a budget shouldn't be doing it at all, because there's no such thing as budget racing, really. Not at this level. At certain levels there are, but not at this level. At this level, you've got to buy the right stuff. And usually if you buy it right the first time, it's a bit more money right out front, but it ends up saving you money down the long run.
Well, Patrick, thanks for coming on and dropping some knowledge on us. I'm sure we can bring you back on at some point because, like you said, you do anything and everything with the car. You drive yourself. I'd like to get you on the Dragazine podcast at some point.
I haven't driven it in years. We need to talk to my business partner, Jason Lee, about that. I'll tell you what, he came back out of retirement driving this year, driving Eric Gustafson's Pro Mod, and you've forgotten how good of a driver he really is, man. He's pretty awesome.
I don't know if we can get Jason Lee on the show because I don't know if he can be as PG-13 is what you can be, because we all know how Forehead can be. So he can
do it. I got faith in it. If not, we'll have Vegas odds on it. Right
on. But
once Vegas opens back up, so
absolutely, Patrick. Look forward to see you at the track, and we'll talk again soon.
Sounds great, guys. Thank you.
Thanks, Patrick.
That is the longest I've ever heard Patrick Barnhill go without dropping an F-bomb.
It's interesting. I didn't know that, because Jason Lee, I always know him as like the suspension tuner. Now he's driving Gustafson's car. Really cool.
Lee's
short
driven
story
for a long time.
Yeah, I just didn't, you know what I mean? Like, I just know him like here on the West Coast anyway. He's a suspension tuner, and then the fact that he's coming back and driving for Gustafson's is interesting and cool, because I know Gustafson fairly well, and then I've seen Jason quite a few times at the racetrack. So really cool little tidbit that he brought us there.
There's the man himself.
And there's David, thank you so much for being on the show, man. This is awesome.
Yeah, no problem. Sorry, I'm a little bit out of breath. I'm trying to finish Stevie's car.
Now, David, we were talking about this before. You've got one bad small block powered vehicle there with El Diablo 2.0. With what you guys know, with your experience in tuning shocks, what's it been like trying to make all that work with a radial tire package on a shock like that with so much power?
We thought originally kind of the weight of the car's a little bit light because of the small block combination, and it was hard to get a shock valved around that weight of the car. And we just started out with our standard Menser 4-way combination, and made our first runs in Bradenton, and found real quickly that we're going to have to do something with the valving to allow the shock to kind of release, for lack of better terms. And I worked with Mark on that, and Mark had an idea of some things we needed to change internally in the shock, and basically I was hands off from there. I let him do what he does.
And what do you think is something out there that a lot of guys struggle with when they're changing shock combinations and trying to get their head wrapped around double adjustable and also like high speed, low speed adjustments? What do you think are a couple of the biggest factors that guys have a hard time with the learning curve of all of it?
I think, normal shock deal, kind of speak maybe for big tire in relation to small tire. They kind of work opposite. A radial tire car, where you would think would need to be loose on extension. That is true a little bit, but once a car actually releases and plants a tire, you would think they normally would need to be loose, but they actually need to be tighter with the more traction that it has.
Something that's interesting is, not only you're an overall tuner of car engines and chassis, you're a driver as well. How does being the driver and the tuner kind of work for you to communicate the performance of the car with, what you're feeling inside the car with how you have to tune the shock? How do you approach that?
Myself, I do drive the car. To be honest, I can feel the shock when you release and when it goes, but we tune more with race pack and shock linears in kind of correlation with the G meter to more tune the shock. So I think from driving, things happen so fast in those cars. You're just really pretty much along for the ride. You can feel it a little bit, but I wouldn't say that you could actually feel by driving what the shock needed to do.
When would you say the need to jump from like a normal double adjustable shock to like a custom valved 4-way adjustable shock? When do you think that transition or change needs to happen as far as power, weight, class, etc.?
I would say that you're only as good as your equipment. So I would say, a custom valve shock at any level would be better to do earlier rather than later. You just have so much more control. I think people don't put as much value in shocks as they should. You think you're going to put a shock on there, spring's going to hold it up, the shock's going to kind of slow it down. But we use that shock to release the tire, to release the car from the tire. We do so much with a shock nowadays that I think it's most important. And I'd say I think it could be used at even an entry level class, all the way up to a pro level.
Another thing I wanted to hit you up on is, you've built some amazing cars, and when you're building these cars that are specific for radials, is there a certain way that you're building them to accommodate to make sure that they can get the most out of these shocks?
Yes. I mean, we build multiple combinations, motor, engine placement. I think everything to do with the chassis has to do with the shock itself. Motor location kind of determines center of gravity. Center of gravity kind of determines how early in the run the shock is required or needed, or how late it's required. But yes, I would say that all things are taken account for prior to the shock placement.
What do you think is, when it comes to tuning on these shocks with a radial tire package, what's the advice that you would give to someone that's trying to learn how to tune on with a radial shock? What do they need to worry about adjusting? What do they need to stress about when they're trying to set their shock up?
I think the most important part is, again, engine. People bring cars to me all the time and have issues. Hey, the car's not working. I think you need to set my shocks. And even with the guys that work for me here in the shop, it's hard for me to explain what all I'm looking at. I'm actually looking at motor height, chassis height, motor placement within the chassis. Then we move into bar angle. The bar angle, I would say, is a direct correlation with the shock. It determines how fast the shock reacts. We look at the bar angle to tell how tight or how loose to set the extension or compression. We kind of set the compression basically tight enough to eliminate the car from squatting when you let go of the button. That kind of forces it into anti-squat and allows it to extend. And from that point, we determine how tight or loose the extension of the shock will be.
That's awesome. That's some good knowledge to have there for sure, because I know that with suspension and shock stuff that you can quickly start chasing your tail. So just knowing an area to start with is going to help a lot of people. That'll be great for our viewers for sure.
I would say that 99% of the guys that bring cars here for setup, typically, everyone can look at mechanically visible things to make sure their bar's in the right hole or their shocks are kind of set the right. But I would say 99% of it is power management. Once you get the car in here and you get to looking at it and you make some adjustments, adjust the shocks, I always look at the power management side of it to ensure that they're just not doing things that are unfeasible. Most of the time people have this extra 200 horsepower and they want to try to use it from the time they let go of the button till the time they go to the finish line. And things just don't always work that way.
Definitely appreciate you coming on, David, and dropping some knowledge on us. And we'll look forward to seeing you back out at the track when we get to racing again.
Yes, sir. I can't wait for that.
All right, it was really cool having David Reese on as our final guest. That was really cool to pick his brain, understand what he's doing, and it's funny because he's digging into other cars. He's building cars right now in this temporary off season, so thank you so much for him for coming on, as well as Patrick Barnhill and Mark Menscer. Those guys can be really hard to get a hold of, so thank you so much for taking your time, guys, and thank you, viewers, again for watching Tech Inspection. Stay tuned. Next week, we're going to come out with another episode of Tech Inspection on another in-depth drag racing topic. And make sure to check out Burnout, Rewind, and Drag Racing Friends right here on Speed Video.